Hey everyone, my name is Brian Cardinal. And today I want to talk about exploiting SQL injection in the order by clause. Now, normally when we talk about SQL injection, we're looking at something that looks like this. It's a SQL command text, and we're concatenating data into it. So we're manipulating the command text with a string concatenation. So this is dangerous because this dynamic data here can be manipulated in ways that we can alter what this command text was intended to do. Oftentimes comes in the way of what we call a union select injection. And this is where we manipulate the command text to append additional data to what was originally being pulled back. So with the statement we saw before, if we concatenate this in, it might look something along the lines of this. So we're doing a select statement from a table foo. We have a where condition, bar equals, and our injection is just simply closing out that bar condition. We don't even care what bar is. And now we're appending a SQL keyword union select to it. And all we need to do here is make sure that we match the columns from the original query, and we'll be able to pull back additional data. So we're putting some dummy data in the first two columns, and then the third column, we're actually using another SQL command called concat, and we're concatenating some data together. And then we're putting a simple placeholder for a fourth one. Uh, Determining how many columns is usually, there's different ways of doing this. You could just brute force it. Try one, you get an error. Try two, get an error. Try three, you don't get an error. Well, three columns. Move on. And the last thing here is we have a hash symbol, which is basically saying ignore the rest of the SQL command text so that we have a nice clean injection statement. Well, that's fine and all well, but what if our injection doesn't happen in the where clause? What if our injection happens in the order by clause? Here we're extremely limited to what we can actually inject as far as legit SQL in the order by clause. There's not too many values that would actually create a legitimate SQL command text. This gentleman, and I'm not going to attempt to pronounce his name because I'm sure I'll butcher it, apologize for that, wrote an interesting blog post. You can check it out on his site here. And he demonstrated or described an injection that we can leverage in a bit of more of an inference attack, a SQL injection inference attack. So we're not going to get the data over the wire that we're explicitly asking for, but we can ask a series of Boolean questions to extract some data. So the injection that he proposed looks a little bit like this. So in the order by clause, we can put some logic, conditional logic in there. So we're putting a case statement, and we are selecting a small portion of the password hash from the admin uh, row. So that's what this hex value is. So this hex value here is a hex representation for admin. So MySQL allows you to represent ASCII text with hex values, eliminating the need for tick marks here. The substring is pulling back the first character, one character length. Uh, so we're pulling off the first character of the password hash. 65 is the ASCII decimal for the letter A. So we're just starting off with the letter A. So what this translates to is if the first character of the admin password is A, we'll order by name, otherwise we'll order by description. So this is one question that we're going to ask, and we're going to get one small piece of information. So if we script these injection attack, we might be able to infer some information. So here I mocked up a vulnerable site. I'm showing the command text for the SQL statement here for demonstration purposes. So the simple first item is just selecting all the products back, and then here's a drop down to change the order by clause. And it's a query, and then we see that we're changing the order by clause by description and do it by price. We're changing it by price, and the value is being passed via get variable here. I've determined that this is vulnerable to SQL injection in the order by clause, and now I want to extract some information. I built a script weaponizing what was described in the blog post that I mentioned before. So I took the same SQL command text and put some variable data into it. So I'm iterating through the hash position as we identify different values, if we're able to identify different values. Uh, I'm also iterating through the decimal number, ASCII decimal number. So I'm iterating through our character set to check if what's that value at each hash position. If this case statement returns true, we'll sort by the first column here. If it returns false and we fail, we'll sort by the second column here. And these are all defined up here. And the last thing we're going to check is how are we going to determine if we succeeded or failed? So this is the injection, and then we need to determine the output. And now I have the data of if we sort by name, the first name that's going to appear, the first text that's going to appear on the page is Dinglehopper. And if the case statement fails, it'll be sorted by price, and that'll cause who's it's to be the first one to appear in the line. And we're just going to check that, and if we get it, we are going to add it to the password hash, and we're going to move on to the next iteration. Let's see if this works. So you can see we actually got something that looks like a hash back, and I had a counter on there to see how many times it had to execute. So 234 times we made a web request, and we extracted this information. Let's see if we actually extracted useful information. Success! The data we pulled back is actually the password hash, how it's represented in the database. Do a little bit of a side-by-side comparison here. 212, FC3. Pretty cool. Well, how do we protect against this? So we oftentimes, when we talk about SQL injection, we say prepared statements or stored procedures or leverage an ORM, but the order by clause can't be parameterized. It's one of the sections of a SQL statement that can't be parameterized. Other areas are table names. If you're dynamically selecting your schema names or your table names, that can't be parameterized as well. So we're cutting out options. We didn't leverage any tick marks in our SQL statement, so MySQL real escape string is not going to do anything here. We don't have any quotation marks or tick marks to balance. So that's not going to work. The whitelist is actually a okay solution for this. We have a finite number of values that the order by column should be. So we can simply be very restrictive and only allow those values to be one of the order by columns. If it's not, we can just completely ignore it, or we can set it to a default order by clause. But this will prevent that attack that just happened from happening. And let's take a look at that. So in this case, I'm going to execute a different script. The only thing that's different is the URL that we're hitting. So I'm hitting a page where I actually implemented the whitelist. So that's just going to be this guy. And again, it's the same script, only hitting a different target. The different target is a page that's implementing a whitelist. If I execute this, it's going to take a little while longer to run. And the reason is we're not getting any success whatsoever. So we've printed back no hash, and we iterated through 1152 iterations with no success because the page always defaulted back to not sorting anything at all. So it completely broke our attack here. So in this odd case of what do we do when we have SQL injection in order by, it is a vulnerability. It can be exploited. We can extract information through it from an inference attack. It can't be parameterized. So in this case, whitelist would actually be an appropriate mechanism to repair this. Thanks for joining me. This has been Brian Cardinale. Check me out at Brian Cardinale.